Hey, Austin Rowland here. This is my Lab 2 video report about lines of charge this week. So the purpose of this lab was to determine the amount of excess charge on a piece of tape. The two charge tapes will interact with each other in this experiment. The distance between these charge tapes will help calculate the charge on each of those tapes. And the data for Lab 2 is just reused from Lab 1. So the experimental procedure is also the same as lab 1. So we create the charge tape by pulling away from the base tape. Next, we determine charge by allowing the tape to interact with a negatively charged pen. We create a second charge tape using the same method, move one tape above the other and record the distance in which the top piece begins to float, and then make sure to record the length of tape piece used for mass calculations. Some central assumptions that we have to make for this lab are that the force of gravity is equal to the electric force for the object to be floating. So the object has to be in equilibrium for this to happen. We assume that the charge tape shares the same charge Q, and for lab 2, we treat each tape like a line of charge for charge distribution. And this varies from lab 1, where we treated the tape as a point charge. Now we have to add infinitesimally small pieces to add up to the total charge. And this different approach means that our calculated charge Q will be different from lab 1. Some of the fundamental principles we use in this experiment are Newton's second law. So the net force of 0 means that our system is in equilibrium, which is how we can assume that force of gravity equals electric force. Then we have our formulas for gravity and electric force, the net electric field, and the electric field of a small piece of tape. So here are the initial data and constants from our experiment. So we have the electric constant, proton charge, gravitational acceleration. Those are all constants. And then some of our data from the experiment is the tape length of 0.204 meters, mass of 0.204 grams, and then separation distance of 0.038 meters. So calculations for the gravitational force are listed below. And then for the electric force, since we know that the system is in equilibrium, it's just going to be equal and opposite in sign to the gravitational force. So the link to the Glowscript computer model code is in the video description. Here is the visualization from that Glowscript code. And at the bottom window, we can see that the electric force and gravitational force are equal to each other in magnitude. And you can also see the green arrows that add up to give us our final electric force. So in the code, we use the electric and gravitational force equations, and we model each piece of tape as a line of charge. And then the output that we just saw on that last slide shows us that the electric and gravitational forces are equal and opposite, and that the smaller green arrows add up to the total electric force. So the results for this lab, we can calculate our charge Q through trial and error. Once we know that electric and gravitational force must be equal, our gravitational force is easy to calculate, and then we can adjust our value for Q until the electric force is equal to the gravitational force. And through that trial and error method, I calculated that the charge on one piece of tape is 2.558 times 10 to the negative 8th coulombs. And this is different from the value in lab 1, which was 1.79 times 10 to the 8th coulombs. What if we'd modeled each of our tapes as a single point charge like in the previous lab? So we have to treat them differently because in lab 2, we're trying to get a more accurate estimate of data. And using that same Q value from lab 1, we can see here on the right that the magnitude of the electric force and the gravitational force indeed do not equal each other. So we need those forces to cancel out for the tape to be floating in equilibrium, since we are using this different method. And this is done through that trial and error method. So why do these estimates differ? So they differ because they account for different amounts of charge. Lab 1 treats it as if the charge is all distributed at one single point in space, whereas lab 2 treats it as if the charge is distributed along the length of the tape. The calculated charge from lab 2 is more likely to be the real charge, and this is because its distribution is more accurate compared to the real tape than the point charge model. And this is all. Thanks for watching.